Hello VidConf. We're going to talk about Environment API and how we intend to make Vite even more flexible. I'm Matias Capelletto, also known as Patak. I'm part of the Vite core team and I work at the StackBridge, where I focus on the Vite ecosystem. And he is Zorro, one of our three cats. It is incredible that we are already on the third edition of VidConf. Evan rolled down with ESBuild to create an amazing piece of shared infrastructure. And that was just the start. Vitest, Volar, Nitro, the whole AngularJS umbrella. Now the meta frameworks have like a whole toolkit to build themselves. In the first edition of VidConf 2 years ago, most of the meta frameworks that choose Vite and were working together were in their beta stage. Even Storybook was just showing how it could run without Webpack. In the second version of VidConf, we welcome to the stage Angular and Redwood. And Evan, you mentioned that Remix was exploring joining the ecosystem too. And not only did it join, like we are going to see a talk from Pedro and Mark this year, but also TANStack Start, Waku, even Ember and Meteor join. And we just keep expanding and improving our shared commons. And now with Rolldown and OXC, Vite is also going to reinvent itself from the inside and get native speed where it really matters. And I want to congratulate Evan and the whole team behind Boy0. It is just incredible now to count with so many amazing developers working on our shared tooling. And I think more than ever, we are now ready to cope with the ecosystem growth. And it will keep growing. The story that we're going to see today about Environment API is also a story of collaboration between a lot of these different teams. And you can see that collaboration in the Vite core repo. Like we crossed 1K contributors. That is incredible. And we also passed 15 million npm weekly downloads. And this is just an aggregation of all our projects doing better together. So how we got here? We got the right design, an ESM-based bundle-less dev server with the speed of ESBuild where it matters and the flexibility and maturity of Rollup during build. And it was at the right time. A new generation of front-end tooling was serving an explosion in meta framework exploration. And the ecosystem really needed a new shared layer. And there were two very key features that I think helping Vite spread. One was using the Rollup plugin API for a powerful abstraction that worked in build and dev. And the other one was an idea from the Svelte team that Evan adapted into Vite that was the unbundled SSR dev shim. We got in our hooks, you could get the SSR boolean and decide to do a different transformation or resolving in SSR compared to the client. And using the built-in SSR low module, you could get HMR-like caching of the modules imported for your server. And just with a few lines of code, you could create a middleware to serve your SSR during dev. For building an SSR app for production, Vite has to do two steps. Like you first Vite build the client and then Vite build SSR to get the server. And using the SSR manifest flag, you could have information communicated between the client and the separate SSR build. The Svelte team and others using the framework as a plugin strategy, so using Vite as their CLI, have long requested a build app command that with a single command, you could build both things. We in the Vite team always recommended users to create their own CLIs for these cases, but this idea of using the Vite CLI really resonated with a lot of frameworks, like Remix also tried to do the same. And they actually, how they managed to do it is that in the client build, in the right bundle hook, that is the last hook, they will hook up their SSR build. So they start with a single bit build command, they got their way. But this was not a first-class citizen. The story continues with the NuxDev SSR. Nux 3 is powered by Nitro, a toolkit to create web servers and deploy them everywhere. And they created with Node to improve NuxDev SSR, using transform request, like lower level primitive compared to SSR load module, and a Node VM based module runner. And they got HMR and source map support in SSR dev environments, and also allows them to run the code in another thread or process, not in the same process where Vite was transforming the modules. This was created by Anthony Fu based on an idea from Puya Parsa. And Vitnode later on went to power Vitest. And from then on, it moved to the Vitest monorepo and was maintained by Anthony Fu and Vladimir. And it powers many other projects in the ecosystem. So at the beginning of last year, we started exploring moving Vitnode into Vitcore. The idea was to have SSR load module equivalent with proper HMR support, and also the module runners, a couple from the Vite server, could give us a lot of extra flexibility. So a revamped Vitnode version was upstream as Vite Runtime API in Vite 5.1. We got very interesting feedback from Cloudflare, Remix, Hydrogen actually used it in production. So shout out to Vladimir for this work. But we could make Vite even more flexible. After receiving this feedback, we started to see that we could use these APIs to actually remove difference between dev and build. First, modern apps are starting to use more environments, client, Node, Edge at the same time. And they also will like to integrate during dev with their local tooling, for example, Miniflare for Workerd. There were other applications like Nux and Vinci apps that also started to use several Vite dev servers to cope with the lack of flexibility of a single one. And there was also limitation with this API, the runtime API, after the positive feedback that we received. First, the runtime API was added as an extension and was not deeply integrated with the rest of the APIs. And the Vite dev server had a single module graph during dev with mixed modules for both client and SSR environment. We had props like transform result and SSR transform results, client imported models and SSR imported models. And this was making it challenge to support proper HMR. And also, how do we configure different environments? For example, like if we want to set result conditions for different, or how we add more environments than just client and SSR. So the first thing that we did is to get back to an idea that we had long ago about we need to separate the module graphs. Instead of having client and SSR mix, we want to have the client module graph, the SSR module graph separated. And if we have that, then we could have more module graph, different environments. And this is where we went back to the drawing board. And at the beginning of this year, we said, okay, what if we could actually redesign the API that we have? Instead of having just an SSR Boolean, starting to have a proper environment abstraction during dev. We could share in the single Vite dev server, keep the HTTP server on middlewares and the plugins pipeline that will be shared by all environments. But then we will let users create different environments for browser, for Node, for Workerd, and each of these environments could be connected to a module runner that is sometimes in the browser, sometimes it could be in the same process, for example, like our typical Node SSR environment, but it could also be run outside in another process, for example, in Miniflare. So this is how we got to Environment API. The benefits of Vitnode Runtime API, but with the ability of create as many environments as a framework needs, with a way to configure them declaratively in a single config, having per environment module graph and plugins, and a consistent API to further align between build and dev. Also, the idea that we can build the entire app with a single build command and make framework as a plugin first-class citizen in Vite. So how do you configure an environment? Before, when we had only client and SSR, we had the root configure, for example, here resolve conditions that will configure the browser. And if you wanted to have something different for SSR, you need to directly say SSR with this fixed option. Now we're going to have an environments option that directly will declare all the environments that the app will use. Client and SSR are there by default, but you can explicitly configure them separately now. If you add something at the root level, it will apply to all environments. And we can define a new edge environment, for example, with a different resolve conditions. And environment provider like workerd could expose in a library a function to directly configure everything that that particular environment needs. So getting back to our example with passing the SSR boolean to plugin hooks, you can see that before we need to pass the SSR boolean to functions like getModule by URL from the module graph. This was error prone as the SSR was optional there. And also, if you wanted to access the configuration, you needed to branch. If it is SSR, you need to access it through a particular path. And if not, you need to access through directly config resolve conditions in this case. And now with environments, we can have the current environment that for that plugin hook directly in the context. So you can access this.environment module graph get module by URL, and you don't need to care about the SSR boolean flag. And also for accessing configuration, there is no branch needed. You can directly say this.environment config .resolve condition, and that will be the resolve condition of the current environment. We also want to allow, as we say, building all the environments in a single command. So we have this Vite build app to build the entire app. And we also have a new abstraction, a Vite builder, that is equivalent to the Vite server. So in the config, if you say builder, build app, you're going to get a builder where you have all the environments, and this will take over the normal process that Vite uses. And you can actually say, for example, yes, I want to first build the client, and then when that is done, I will build the SSR and RSC in this particular framework together in parallel. And in the middle, you can also do other kind of things in the same process. So if you see how the Vite server and the different environments like APIs are changing, you will see that before we had a lot of things exposed from the Vite dev server, and this needed then you needed to pass the SSR boolean everywhere. Or if you access like in a single module, for example, you will say like module.ssr imported modules. Now with environment API, some things remain in the same, like http.server.http.middlewares. This will stay in the same way as before. This is shared for all environments. But then we are moving transform request from the server plus the SSR boolean to the current environment. Also the same with the plugin containers, or if you access a module, you are directly going to say module.transform, module.imported modules, because that module is only for one particular environment. And the same thing that we saw before with environment.config, instead of having, as before, having to access through a particular path for SSR or for the client. So getting back to our typical SSR setup, we have an Express app and a Vite dev server in middleware mode, and we connected all the middlewares from Vite to the Express app, and we have the typical middleware from our documentation where we grab our raw template, we use transform index HTML to have the HTML template, and we're going to use the Vite dev server SSR low module with the entry point of the server, And this will give us HMR-like caching of all the imported modules. And using the render function, we can render a particular root, the component for that root, in a string and inject it in the template. And if we see how this will change with dev environment and module runner, first we need to see that even if it's not explicit, we have here a default client environment and an SSR environment. And the SSR environment will have a default runnable dev environment, how it's called, that already creates a module runner in the same process. This is how SSR low module always work it. So if we actually explicitly define a new environment, let's say the client is already there, but we have a new one called server, in this case, that is distinct from the SSR one, we can get the same that we had before using the server, the environment server.import with the entry point of the server. And the difference now is that instead of like just HMR like caching, we are going to have full HMR. We can use import MetaHot and all the APIs that we know. And this is, again, the default way to create an environment. When you don't specify this create environment, it lets you modify the environment instance. And the default one is using create runnable dev environment. All these APIs are still in flux. So came discussed with us. And so if you check, you can actually define other kind of environments. Let's say that your environment provider can give you a create edge dev environment that will later on need to be paired with a module runner. This time the module runner in a different process or like thread. And there are some APIs that we are still discussing with the ecosystem, but it's probably the environment will have some kind of way to dispatch a fetch, and then we can do SSR in a standard way across environments. And this could sound a little bit complex, but first of all, this is going to affect mainly framework and environment provider authors. So it's not something that final users will need to worry about. What we get with these new APIs is that now the BitDev server can be running in Node, but then the module runner can be created in another process or thread. For example, let's say that we create it inside of Miniflare, so we emulate workerd during dev, and this runner import is going to directly run inside Miniflare, and all your application code that normally will run during already in production in workerd is a lot closer now, because it's not running in Node and then connecting to Miniflare from some APIs. It's all running inside of Miniflare here. Let's check a quick example. This is from Hiroshi, that he gave us tons of feedback, so thanks a lot to him. And this is doing SSR on the edge, running in Miniflare. So we have here our environments. There is going to be a client environment and a workerd environment, and we are going to configure it using a plugin, in this particular case, that he created. We are still working with frameworks and environment providers to see what is the right abstraction here. And this is going to set up the module runner inside Miniflare, and is going to connect it to our BitDev server. And if you check, for example, you have here builder, build up, and it first building the client and then building the workerd server. If you see in entry server, we have the code that we checked before. So here we are going to do a render to a string from Ragdom server to get the SSR HTML, and that we are going to inject it and do the response in our template and answer. And if let's go to here and then do a pnpm run build of app, and then we are going to see that not only the client was built, but also the SSR in the same process. And we have our dev server already started. So if we go here, we can see that it has already been iterated. We can play with the counter. This is a diagram from Igor, so thanks to him. This the dev server, the dev browser is doing a request to the BitDev server, and not only the BitDev server, and in this process we were transforming code, but also before in bit 5, the SSR code that was rendering was also rendering in Node. And with a platform proxy that was created by Cloudflare, you could communicate and use different services inside Miniflare. But your application code was running in a different environment. And the idea is that in bit 6, we could move that application code that was doing SSR, that server, we could move it to run directly inside Miniflare during dev. And the code will still be transformed in Node by the BitDev server, but now your application code is running in the correct place. And if we see the Bit plugin inspect, this is an alpha version of it that already supports environment API, so make sure to install that one. And you can see that now we have this client environment here, and this is like our entry client that has like the page and some styles. And you have also the workerd model graph. And now this in workerd, it is a different model graph. These model graphs are separate now. So let's look at some use cases. As we said before, one of the main drivers is to make the code that we have in production be as close as possible to our dev story. So we expect that not only for Cloudflare, but for other environment providers, this is going to be important. Mainly using Cloudflare here as an example because we got a lot of involvement for them and really great feedback, so shout out to them. We could explore also going back to a single dev server in some of the cases that currently require several. React Server Components is a good example, and Vinci apps that also use different bit servers for each router. And yeah, like shout out to Vinci first, that is powering now Solid Start and TanStack Start. And yeah, maybe the environment API could help like simplify some of the things that at the same time were inspired by the needs Vinci had. And also maybe framework like Nux could explore in the faraway future, also going back to a single dev server. There could be also interesting use cases for React Native, and maybe the ability to have more flexibility in how environments are configured could help there. And in the same line, we always said that Bit was browser only. Still, Tori and Electron, they all had plugins to make it work, but maybe we can help with that cases and make this more as a first class citizen. And also isolated web apps are a good example, or web extension. Maybe we can have these libraries that provide these environments to simplify their use. Vitess is another interesting use case because what came from Vitess as VitNode to runtime API to environment API, and now like Dev Environment Model Runner could get back and simplify the implementation of Vitest later on, making it more maintainable. And we will see if a little bit faster too. So we are very excited about what the ecosystem is going to build on top of Environment API. And yeah, it's going to be experimental at first. It's going to be released in Bit 6, but you can already try it in the beta. And we really need more feedback and experimentation. So check out for, if you're a plugin, a framework, or a tool author, check out if this API is flexible enough for your use cases, create new environments, and please check backward compatibility issues. Like Bit 6 is going to be backward compatible with Bit 5. Even the model graph, for example, the mixed model graph is still there with the same API. So the idea for now is that we want people to move from Bit 5 to Bit 6 without any problems, while we keep iterating a little bit more, so we get more feedback and we get this that is going to be one of the biggest API changes in Bit history. Like, yeah, we have to get it right together. So you have a pinned discussion in our GitHub repo, or you can use the contributed channel. And yeah, we wait for your feedback. Thanks a lot, VidConf, and thanks again to every speaker, all the community, to Stackblit and the community partners to make it possible. Again, it is amazing that we are in the third VidConf. Enjoy the rest of the talks.